Subscribe now.
Assuming that you have been asked to do the inverse DFT. Assuming that you have been given the task and you have been given the x of k equal to, let's say, let's use the normal sequence 13 and -3 to find the inverse, because it was in the analog domain and you have converted it into the digital domain. Now you are done with whatever you want to do, and then you want to bring everything back to the time domain. So how do we do that? That's where the inverse DFT also come in handy. So for the inverse DFT, the formula that we wrote for it was x of n should be equal to the summation of k equal to 0 to n minus 1, right? And then x of what? K exponents j 2 pi over n, and then nk, right? Nk. So looking at this, remember that in my previous representation of the formula that I wrote, there should be 1 over n over here, which is the inverse over n here. So now we know that our n is equal to 2. So when we substitute it into the formula, we are going to get x of n to be equal to 1 over 2 exponent k equal to 0, and then n minus 1, and 2, and which is 2 minus 1 is 1, and then x of k, and then exponent j pi nk. So now this is what I have for the inverse simplification. So assuming that n is equal to what? 0. When n is equal to 0, everything here goes to 0. So we are now going to get x of n equal to 1 over 2 summation of k equal to 0, and then 1 x of k. And then since n is equal to 0, everything is going to be 0 here. So now we can say that we are going to have 1 over 2. For k equal to 0, we are going to get x of k, right? We're going to get x of k, which is 0. S of k, right? And then here is supposed to be 0. And then the next one, k equal to 1, we are going to get what? X of what? K. So here is k 0 and s of k 1, right? So this is what we have. So the exponent is 0 to it. So in doing this, exponent 0 is 1. S of k from our x of n equal to 13 and -3. S of k 1 here is what? 13. S of k 1 is 13. And therefore we are going to get 1 over 2 multiplied by 13 and 1. 13 and 1, right? And remember that for the sequence, since we have k equal to 0, the sequence must be plus. So 13 multiplied by 1 plus s of k1 is what? -3 multiplied by 1. So when we do that, we are going to get 1 over 2 multiplying by 13 minus 3 is what? 10. And then when we do the 2, we are going to get what? 5. Doing same for the others for n equal to, or let's say n equal to 1. When n is equal to 1, we are going to get x of n to be equal to 1 over 2, right? 1 over 2 exponent k equal to 0, and the 1 x of what? K exponent, since n equal to 1, we are going to have 2 pi. Let's say the 2 has already been cancelled, so let's say 2 pi over n, and then nk. And now we are saying that this n equal to 1. So at the end of the day, we are going to end up getting 1 over 2 k equal to 0, 1 x of k exponent n is equal to 2, so we eliminate it to exponent j pi k. Since we have exponent j pi k, right, we are going to get something like 1 over 2 x of 0 exponent 0 plus x of 1 exponent j pi. So based on this, x of 0 is what? 13 from what I stated earlier on, multiplied by 1, then plus. When we simplify j pi, we are going to get 1, -1. So based on the fact that it's -1, we are going to get 13 plus, let's say 13 plus 3, because 3, because since this expression is going to give us -1, it's going to be 13 multiplied by 1 minus, right, minus 3 multiplying by, because the 1 here is -1, so the minus 3 is going to give us 13 plus 3, which is what? 16. So 16, remember that we have 1 over 2, so we are going to get 8. So at the end of the day, we have our sequence back as x of n equal to what? X of 0 is what? 5, and then the x of 1 is also 8. So this is how the n equal to 2, which is the 2-point DFT, is being calculated. So we are going to solve some more examples on 2-point DFT and 4-point DFT. So these are the examples that we have. So given the following sequence, we should use direct computation to find the DFT of x of n equal to 1, 1, and then x of n equal to 1, 0. So this question here will be a trial question for you, and even the one that I'm solving here, you can pause the video and use the knowledge that you got from the previous tutorial to try your hands on them. But for the meantime, let's try and proceed to solve this example. Using the forward DFT, we have x of k to be equal to summation of n equal to 0, n minus 1, x of n, exponent negative j, 2 pi over n, nk. Excuse me. So now, where k is equal to 0, 1, up to n minus 1. Since the 2-point DFT is the same as what we did earlier on, right? So the same process that we passed in solving the first example, we are using the same process. So assuming that k equal to 0, we are going to get x of 0 equal to summation of x n equal to 0, n minus 1, x of n, exponent 0, right? Because k is equal to 0. So whatever happens, we are not going to get it. So in that way, when n equal to 0, we are going to get x of 0 for this one, x of 0 exponent 0, plus when n equal to 1, we are going to get x of 1 exponent 0. And looking at the example, x of 1 is 1 and x of 0 is also 1. And therefore, we are going to get 1 multiplied by 1 plus 1 multiplied by 1, which is equal to 2. Now, considering k to be equal to 1, we are going to get x of k to be equal to summation of n equal to 0, and then 2 minus 1 x of n exponent j pi, and then n, and k is 1, so you bring 1 there. I didn't bring the over n there because the 2 up there has also cancelled it out since the number of sequences 2. So based on that, we are going to get the exponential part to be exponent, remember it's negative j pi, and then n. So for n, so let me write it here. x1 equal to n equal to 0, 1, x of n, exponent negative j by n. For n equal to 0, we are going to get x of k. Let me write it straight away. For n equal to 0, we are going to get x of 0, and then when we put 0 up here, we are going to get exponent 0, plus when n here is equal to 1, we are going to get x of 1 exponent negative j pi. So our work is to simplify this one of this part of the exponent using calculator. Using calculator, we are going to get pi is equal to negative what? 1. So when we get a negative 1, what we can do is that we will rewrite it x of 0, exponent 0 plus x of 1, right? Multiply by negative 1. X of 0 is 1. Multiply by 1 because this one is 0, 1. Minus, here it's also 1, right? And then we are going to get 0. And therefore, our sequence x of k is equal to 2, 0. 2, 0. So now, this is for the first question. You can feel free and pause the video and then try your hands on this. You are supposed to get for the 1 and then 0. For the 1, x of n equal to 1 and then 0. You're supposed to get 1 and 1 as the final answer. So try your hands on this and compare it with whatever you are going to get. And then the trial question that I gave it to you here, 1 and then negative 1. For the 1 and then negative 1, you are supposed to also have an answer 0 and 2. So this trial question that I gave it to you here, the answer that you're supposed to get is supposed to be 0 and 2. So please pause the video and try your hands on it. If you have any question, you can put them in the comment section. So thank you for watching and see you in my next video.